what's up, guys? This is day one of our new unit. So we're going to start getting into probability in this next unit, which is something you've seen before in previous classes. Okay, so we're going to spend today just kind of reviewing some of the basic ideas of probability, some of the basic scenarios you're going to run into. Just know we're going to get a little bit more complicated than this, but it's kind of a good way to get our feet wet and get started and just remind ourselves of how we handle some of these situations with probability. Okay, so we're going to go section by section here. This is the probability review notes that you should have, so hopefully you have these printed out, or you can just follow along and kind of copy them down as I go. All right, so the first situation for problems 1 through 5, we're going to look at a 6-sided dice, so normal just 6-sided die. All right, so you should be familiar with this. Like I said, there are 6 sides of this. We all know that each side has a different number, so that has 1 die, so that's 1, and 2, and 3, and there's 4, 5, and 6, right? So this is just your normal dice. All right, so the first question here, number 1, asks us how many possible outcomes there are if you roll the dice once. And that's a really important question because if you remember back to some probability, we're going to be making fractions to talk about these probabilities, and the number of total outcomes or possible outcomes is always going to be the denominator or the bottom of your fraction. Okay, so since there is 6 different sides to a dice, there are 6 different possible outcomes. Okay, so if I look at number 2, it's saying what is the probability of rolling a 1? So me taking the dice, rolling it, and getting a 1. All right, so like I just said, there are 6 different sides. Only one of those sides is 1. Okay, so there's only one side that has a 1 on it out of the 6 total sides. So that is our fraction for probability. Okay, when we do probability and fractions in general, there are really 3 different ways that you can write your answers. You can write it in a simplified fraction form like this. Okay, but you can also convert it to a decimal. So you can just put in 1/6 in your calculator. We're just going to round to the thousandth or the third up to 3 decimal places. So this is 0.16 repeating. So we're just going to say this is 0.167. And honestly, the decimal form is not always as important with probabilities, but the reason it does help us is because it allows us to get to the third form, which is percentage or as a percent. So we know to convert a decimal to a percentage, you're just going to move this decimal place to the right twice. So there's a 16.7% chance of rolling a 1 on this dice. And the percentage is something you see a decent bit, so it's important that you know how to convert that. Okay, so we're going to do the same thing for all these other ones. We're going to go fraction, then decimal, then percent. Okay, so for number 3, probability of rolling a 4. Same thing here. There's only one side that is a 4. So out of the 6 sides, only one of them has a 4 on it. So there's a 1 out of 6 chance of rolling a 4, which again is 0.167 as a decimal, which converts to 16.7% as a percentage. Okay, for number 4, what is the probability of rolling the odd number? So if you look at the dice, you have 1, which is odd. You have a 3, which is odd, and you have a 5, which is odd. Okay, 2, 4, and 6 are even, so we don't want those. So we have 3 different odd numbers out of the 6. Okay, so that's a fraction. That's not a simplified fraction, though. So it's always a good idea to simplify this down, which will be 3/6, we know, simplifies to 1/2, which as a decimal is 0.5, which as a percentage is 50%. So you have a 50% chance of getting an odd number. Okay, getting a negative number. There are no negative numbers on the dice. Everything's positive here. Okay, so getting a negative number, you have 0. You have 0 chances out of 6, which as a decimal would be 0.0. There's a 0% chance. Those aren't quite as important, but kind of sticking with it here. You just have no chance of getting a negative number. That's the important thing for you to know there. Okay, so that's dice. We're going to see a lot more situations with those in the future, so it's important you kind of understand that. Next situation is very simple. It is flipping a coin. So we all know about a coin. I have a quarter here. A coin has 2 different sides. One side is heads, other side is tails. All right, so when I flip a coin, the total number of outcomes I have are just 2, heads and tails. So that's going to be the bottom of my fraction when I move ahead. So what is the probability of flipping heads? Heads is one side out of the 2 total sides. So there's a 1/2 chance, which is 0.5 or 50%. All right, probability of flipping tails is the same thing. Tails is one side out of the 2 sides. So 0.5 or 50% chance. Okay, coins are fairly easy. It's either heads or tails. All right, next one, deck of cards. This is one that some people aren't quite as familiar with, so I'll do my best to explain this a little bit. Okay, the first thing to understand when you have a deck of cards, all right, here's my deck of cards, is that there are 52 total cards in this deck. So if I have a complete deck here, which I do, there are 52 total cards. All right, so that's important, once again, because that's going to be the denominator of my fraction. It's going to be what I work with on the bottom for these. Okay, within a deck of cards, there are several different subgroups we can talk about. All right, if you notice, the first group is dealing with color. All right, some of these cards are black, some of these are red, and actually exactly half of these cards are black and half are red. So we have a total of 52. Half of that would be 26. So there are 26 red cards total and 26 black cards total. So that's the first way we break this down. It's half and half. Okay, so if I jump to number 9, what is the probability of drawing a red card? Well, we just said there are 26 red cards. They tell us that out of the 52 total cards. 26 out of 52 simplifies to 1/2, which is 0.5 or 50%. Okay, so when I break it down by color, I've got a half chance, half red, half black. Okay, my next subgroups are hearts, clubs, diamonds, and spades. Right, we call these suits. So we have 4 different suits. Each suit has 13 total cards in it. So I'm going to use these aces as an example here. So our first suit is what we call a spade. And we have a club. And we have a diamond. Then we have a heart. All right, spade, club, heart, diamond. Okay, so these break down, and if you notice, there are 4 different ones, so they're each 1/4 of the deck. Okay, so when I go to find this next question, number 10, and it says, what is the probability of drawing a club? Well, right here we see there are 13 clubs out of the total 52 cards. All right, which, like I said, if you simplify this, this is 1/4 of the deck. We all know 1/4 is 0.25 as a decimal, which is 25%. Okay, next, what is the probability of drawing a queen? So queens are the cards, let's see. Queens are these cards. Okay, they're a specific type of card. And so if you look up at the description, it says there are 4 of each card or each type of card. So there are 4 of each type. So there are 4 aces, 4 2s, 4 3s, 4 4s, and so on and so forth. But there are 4 queens. All right. So there are 4 queens in this deck of 52. So when I find a probability of drawing a queen, I know there are 4 out of the 52 total cards, which if you simplify it is 1 out of 13. Okay, this one we're going to need a calculator for, so we'll do 1 divided by 13, and it'll round to 0.077 as a decimal, which is 7.7%. Okay, last one. What is the probability of drawing the ace of spades? So the ace of spades is a very specific and popular card. It looks like this. There's only 1 ace of spades in every deck of cards. Alright, so when I go to find this as a probability, there's only 1 out of the 52 cards, which is an ace of spades. So 1 out of 52. Cannot simplify anymore. It's already simplified. But I also will need the calculator. 1 out of 52 is about 0.019, which is about 1.9%. Okay, so make sure you remember the deck of cards. There are 52 total, and then you have these different subgroups, and there'll actually be another handout, which will be you'll have access to, that kind of shows you all the cards in the deck. Can hopefully help you remember some of this. Okay, next two sections deal with scenarios that we are given. So the important thing in these scenarios, and you have marbles and socks we're drawing, is that you know the total amount of, in this case, for number 13 through 17, the total amount of marbles we have. So we see that we have the numbers broken down by color. We want to find the total. So to find the total, we'll just add them up. So when you add these, you see that there are 21 total marbles. And that is important because we need a denominator for our fractions. So the denominator in this case is 21. Okay, 13. What is the probability of drawing a green marble? So it's as simple as seeing there are 8 greens. So if I have 8 green marbles out of this total of 21 marbles, okay, I can plug that into my calculator to get a decimal. I get 0.381, which is 38.1%. Okay, next question. What is the probability of not drawing a green marble? So getting anything but a green. Alright, so I know I cannot draw a green, but I can draw a blue, I can draw a red, or a white, because those are all the not green marbles. So if I do 7 plus 4 plus 2, I end up getting 13 marbles that are not greens out of the 21. Alright, 13. Let's clear out here. 13 divided by 21 will get you 0.619, which is 61.9%. Okay, if you look at those last two questions, this is an example of something we call complements. So what that means is that between these two cases, everything in our bag of marbles is covered. Okay, so I have the probability of drawing a green marble and then not drawing a green marble. So if you add these two fractions up, 8 plus 13 would give you 21. So you have all 21 out of 21 cases here. Same thing, if you added these percentages up, you would get 100%. So just keep that in mind as we go. We're going to deal with those more in the future. But any two cases or any number of cases that cover everything that's possible are what we call complements. Okay, moving on to number 15. What is the probability of drawing a white marble? Okay, white marble is, there are 2 white marbles. So there are 2 white marbles out of the 21 total marbles. Okay, so we're just going to plug that in. 2 divided by 21, you get 0.095. Alright, so 0.095, which is a 9.5% chance. Okay, number 16, what is the probability of drawing a red or green? Red or green, either one. Okay, when you see the word or, go ahead and get used to this. Or kind of tells us to add, right? We don't even have to think about it that complexly yet. We can just think about red or green. So I'm happy to draw a red, so these 4 reds, or these 8 greens. So I'm cool with 8 and 4, which is 12 out of our 26 marbles, which we could simplify, but for the sake of this, we're just going to plug it in and get a decimal, which is 0.462. So you got a 46.2% chance of getting a red or green. Okay, last problem. Blue, red, or green. Or excuse me, blue, red, or white. So same thing here. You're happy with any of these, or kind of tells us to add. So blue, there are 7. Red, there are 4. White, there are 2. This is actually the same exact problem as number 14, just written in a different way. So if you add up the blue, red, and white, you'll get 13 out of the 21, which is 0.619, which is 61.9%. And that's our marbles. Okay, last one. Socks. Same situation as the marbles, just different item. So we want to find the total first. So 5 plus 8 plus 9 plus 4 gives us 26 total socks. So that's going to be our denominator. Alright, when you reach into the drawer without looking, what is the probability of pulling out a white sock? Well, we have 5 white socks out of 26 total socks. So I can plug 5 over 26 in and get 0.192, which is 19.2%. All right, probability of pulling out a purple or black sock. We're happy with both. So or means add, which just means that we take the purple socks, which is 4, we combine it with the black socks, which is 12. So you have a 12 out of 26 chance. And I realized I just made a mistake. I got ahead of myself. All right, let's go. Jump back up. Sorry, guys. Follow me here. Jump back up, number 16. This should have been out of 21. Maybe you caught that as we did it. Maybe you're yelling at me through this video. All right, so you have a 12 out of 21. We're jumping back up to number 16. Let's fix it. 12 divided by 21. That's a 0.571 or 57.1% chance. Okay, hopefully you got me on that one. If not, you did the same mistake I did. All right, this is our 12 out of 26 chance, which you can simplify to be 0.461 or 0.62, which is 46.2%. Okay, last one, probability of pulling out a brown sock. Well, if you come up here, there are no brown socks. Whoops. So there are no brown socks. So that means we have a 0% chance or 0 out of 26 chance of getting a brown sock. Okay, hopefully this jogs your memory on some probability stuff. You're going to use it more as we go in the coming weeks. But make sure you get this taken care of. If you have any questions, ask your teacher. They can help you. There'll be a little practice after this just to keep you up to date with it.